All right, so we're going to talk about the answers to this worksheet here, and you guys have had a chance to fill in these blanks. So let's see how close you got here to the correct answers according to this video that we watched, Bill Nye video. So electricity is the flow of tiny particles called what? Electrons is correct. Electrons. Very good. Not with a K, not with a K. We're not in ancient Greece, so we're going to write that with a C there. Okay. Electrons are part of what? Okay, so that's a funny word, but they are a subatomic particle is what they're called. So they're parts of what? Atoms is the correct word here. Apples? Well, yeah, apples too, I guess. Probably could have put anything in this blank, but the best answer is atoms. Okay, the word circuit means what? Circuit. Any guesses there? The word circuit means, what does the word actually circuit mean? What's circ? Think about circle. Circulate. A loop, okay, it means to go around. So you might have something like this, but it means to go around is what the word circuit actually means. Or you could just put around. Therefore, a circuit it's a pathway, you could put, or a closed path around which electricity or water, they talked about water in the water hose in the video, around which electricity or water flows. So a path. So a circuit is a path. So it can go whatever. It doesn't have to be perfectly circular, but it kind of has to connect. Now there might be some kind of battery or something here, power source that would push the electricity around this path, just like kind of race cars on a track. Okay? But the word circuit, think about circle, or to go around and to come back to the same spot. In a circle, you know, you can go around the circle and you always come back to the same spot every time you go around. It's similar. Okay, number 4. Electrons flowing through a wire can be compared to blank flowing through a hose. Yeah, I think that's water. Water. Once the flow of electrons or water is going, blank is performed. Electricity, so if the electrons are flowing here, there might be something like a light bulb or something in this path. And so these electrons actually would light up the light bulb, right, if they're flowing through here. So the word here is work. It actually can do work. Electricity can do work by lighting up the light bulb, or by turning the motor on, right? Or by turning the radio on or something. Electrifying your guitar amplifier or whatever. Yeah, question?
If you were to just put out like a battery and a light bulb on one end and connect them to a wire, and you didn't have like a loop.
All right, so you would get shocked in a bumper car. Now, remember the bumper cars? Have you guys ever been in a bumper car? It's these kind of things that kind of look like this, and there's a person sitting in there driving, okay, and they're in there. On the back, right, they have this thing like this, and there's like this metal cage, right, kind of that this contacts. And so as this car moves around, it's contacting sort of the metal floor, and it's contacting the metal roof up there, and as it drives around. So this electricity is passing from this charged metal roof into the car motor, whatever, and through the ground, so it's kind of giving energy through the car motor. So that's why you have those little things above you kind of touching something, and then it's on this, and the floor is always kind of like a sheet metal, right? It's like metal floor. Okay, so you would get shocked in a bumper car by touching the ceiling and the floor at the same time. So if you had a really tall person, really, really tall, and they were like reaching up and could actually touch the top and stand on the bottom here as well, they would not be good. They'd be like, ah, light me up. Yep.
Would they be electrocuted?
Well, it depends how much electricity would be flowing through them, whether they would die or not, or they would certainly feel a pretty bad shock, right? So probably wouldn't be good. Yeah, no, wouldn't be good. This means that you are completing the what? What would we call that? Completing the circuit is correct. Yes, you're completing the circuit. Electricity from a wall outlet has enough energy to stop your what?
Heart.
Heart is correct. Yes, to stop your heart. All right, number 7. Electricity is the blank of electrons. What'd you put there? Flow is correct. The flow. Because electrons, jump or move. So we could put move or jump. Yeah, I like that. Move or jump from atom to atom. Yeah.
Well, instead of flow, you put movement.
The movement of electrons, yeah, that's fine, I guess. Movement of electrons. I mean, flow means it kind of like keeps going kind of in one direction though. So that's a better word for it. Movement could be just back and forth. So flow is definitely a better word, but I get what you're saying.
So one direction isn't like one direction in this.
No. Yeah, good. Thanks for the clarification. Okay. Okay, materials that allow electrons to move easily from atom to atom are called what?
Conductors.
Yes, conductors is correct. Conductors. Materials that do not allow electrons to flow easily are called? Yes, insulators. Very good. Awesome. Okay. Blank are materials that are somewhere in between. What would we call those materials? Neutral, not correct. Yes, semiconductors is correct. Good. Semiconductors. All right, number 11. Blank is the force or pressure of electricity, and it's compared to the amount of water pressure in a hose. Starts with a V. Voltage. Yeah, voltage. So if you have high volts, if you see kind of an electricity, kind of a power station, and they have signs on the boards, boys in the back, listening to me, please. They have signs on this fenced off area where there's electrical transformers and all these wires and poles and stuff. And you see like 20,000 volts, danger, 20,000 volts. The V is voltage. So that's basically the power. Think about a water hose. If you have a lot of pressure in a water hose and you like turn on the water hose and the water shoots out, across the yard, that's a lot of pressure, right? If it's just a dribble out of the hose, that's low pressure. So high voltage would be a lot of pressure. So if you were to complete that circuit, there would be so much pressure, the electricity slamming through each of your cells, you would get electrocuted, high voltage. So it's not a good idea to get in the way of this high-powered electricity trying to find a ground. Yep.
How much volt, like approximate amount?
Number 12. Blank is the amount of electricity and is compared to the amount of water in a hose. Blank is the amount of electricity. This might have been a tougher one, but current. Or if you put amps, amperage. That's the sort of unit for current. That's the amount of electricity. So there's force, and then there's the amount. Got it? Force and amount. You can have a large amount at a low force. It'll take longer to kind of deliver, right? Or you can have a smaller amount at a higher force, which would happen very, very quickly. 13. I think this is the last one on your page. Yeah, I don't know. Blank is the term for work performed by electricity. Blank is the term for work performed by electricity, and starts with W. Waves? No.
Wonderful work.
Work? No. Those are good try. Watts is correct. Yes, it's watts. Watts. Now, yeah, you would have pressure, you would have amount of electricity. Now, watts would be the how much work it could do. So if you think about a heater, right? If you think about like a space heater or something like that, that's got all these little filaments here that light up and get glow red and produce heat, right? Something like that. Then they would have like 1500 W on it or something like that, right? Or 750 W. So that W stands for watts, and so that's basically how much power it is using. And so if you have higher number of watts, it's going to use more electricity to do more work. So it would make this would be hotter. The space heater would be much hotter. 750, this would be, you know, half as hot, half as much work. So if you have electrical appliances and stuff, they would be measured in watts. That's the amount of work that they could do. Okay? So it's basically like power over time. Any questions? Okay, so there are the answers for your worksheets.